get going. So like I said, this will be geopositioning for drone data, which RTK solution fits your needs. Now, the purpose of this webinar is we've had a lot of questions recently about the various methods of geopositioning available for drone data. While there are more ways than what we will touch on today, these 5 methods that we're going to touch on are the most commonly used today that we've found. While we are going to be making recommendations throughout this webinar, I want to make something abundantly clear. There is no one perfect solution for processing GNSS data. Each method has pros and cons, and the right solution for one company may not be the right solution for another. Some factors that you have to take into account when choosing a solution are: how big is your area of interest? Larger AOIs will need solutions that are not limited by connectivity or bandwidth. What cell service is going to be expected for the majority of your jobs? Some of these solutions require a strong and unwavering cell service connection. If you're going to be working in rural areas or places where you don't know if there's going to be cell service, some of these methods may not be for you. What kind of buildings are going to be in and around many of your jobs? Large, dense urban areas can increase the error of some base stations, letting your live RTK feed vary significantly and adding unnecessary error into your data sets. And finally, what kind of existing equipment does your company have for processing GNSS data? Do you have something that your company knows very well, has used in previous workflows, and something that you'd like to incorporate into a drone solution? Or are you looking to branch out, have the room in your budget for a different kind of solution that may be more user-friendly or fit your needs better? Finally, are you going to be tech savvy enough to program a workaround for some existing equipment? Do you have a firm knowledge base for the existing equipment that you have, or is it something that you just plug and play? All of these factors and more are things that you need to discuss or at least think about when choosing to make the jump to the high efficiency advanced technology of a drone solution with RTK. Now, some of the factors that we considered when comparing and contrasting different methods are the accuracy of the data, the reliability of the method, and the ease of use of each method. Accuracy is the precision of the data after post-processing. This has nothing to do with how long the processing portion of your workflow may take. With some of these positions, inputting and selecting data points in post may give you incredibly accurate results, but at the cost of several hours, if not days, of processing time. The best way to measure the actual accuracy or the geopositional accuracy of a data set would be to use a traditional base and rover or a total station or whatever you have and check a point that was not used to correct the data set, something outside of what was made in the data set, and compare it to the measurement that your data is giving. If you take that third data point and put it into your data set and it comes back 2 or 3 inches off, then you can be fairly certain that your error for the entire data set is going to be 2 or 3 inches. Now, the reliability is the efficiency of the method to collect reliable data that does not have to be revisited or reflown. These issues can cause data to be lost or whole days of survey to be wasted because of the lack of reliability. This also includes reliability during inclement weather or wind emergencies. Now, if a method may be accurate, but if you lose connectivity or if it isn't as reliable, it doesn't matter how efficient or accurate the data is. If it all comes back bunk, you're going to have to go back and refly, and nobody wants to do that. Now, ease of use, finally, is how easy a method is to integrate into your current workflows. With large projects, ease of use and efficiency of workflow can save you hours of setup and post-processing time for every single job worked. Now, those hours may not seem like a long time, but if you're going to be working several jobs a week or even several jobs a day, that efficiency is going to be paramount to collecting data. Ease of use can also include how large a learning curve there is for a certain workflow. The larger the learning curve, the more room there is for mistakes or breakdowns on site or in post. And that can be frustrating for everybody, enough so that you may want to look for another solution. These are the methods, those 5 methods that we researched. So PPK processing, there's no local base station, but publicly available survey correction data on marked targets in your AOI. This is one that has been around forever. Everybody knows about it. Network, RTK, NTRIP, no local base station, but a direct drone connection to an NTRIP network. This only works for some drones. Some drones do not have this capability. Third-party base station is a non-DJI base station like a Topcon, a Trimble, collecting our RINEX data separately and combining it in post. This is a different version of a PPK that everybody knows. Third-party base station with an NTRIP, rather than using the NTRIP directly with your drone, you're broadcasting it through a base station configured with an NTRIP network that broadcasts correction data directly to the drone. And finally, last but not least, the D-RTK2 is a base station made by DJI specifically for live streaming correction data to a drone. No volume. There's a question on here, no picture, no volume. Can everybody hear me? All right, looks like we had some technical trouble here, but I'm glad everybody. All right, so let's get into these various methods. Now, PPK processing only, like I said before, it's been used the longest. It does not use any RTK data, but instead georeferences photo data with marked points. Now, how you would go about doing this is you mark or find points with targets and traditional GNSS data, and then you fly your area of interest, making sure to capture those targets in your data, and then going back in post and inputting that data into your data set. Now, some of the pros and cons with this method, it is, like I said, it is the oldest tried and true method. With proper care and effort can result in accurate results. This method has no backup, however, and no real accuracy until it's been processed. All that means is that the accuracy that you're gonna see is going to be in the post, and there is no way of telling if your data is going to be accurate the day of, which can lead to many revisits to a site if your ground control points were not marked correctly, if they didn't show up in your data, or if you find out later that some of the equipment that was used to mark it was not functioning properly, like some kind of satellite or battery issues. Now, when it comes to marking your points, you can use traditional GNSS, like a base station and a rover, or a total station, or even if you don't have access to this, if you're going to do some construction, there's always going to be a pre-construction survey of a data site, and you can see if you can get some data points from there. If you have nothing else, last line of defense is the NOAA website here. It has publicly available survey points from the national database. These are available on this site. You can take down the URL there. Now, long base times between survey data points and sloppy marking can result in large errors with no way of knowing and no backup, rendering entire data sets useless. This method is a great way to introduce errors into your data set with human error. If you may have awesome data from your GNSS base station and rover. However, if you go into your data set and post and inaccurately mark the data points, with your GNSS data, it's just like you didn't even take the data yourself. So this method is traditionally easier to use, highly accurate. It is neither highly accurate nor incredibly reliable in the long run, and in my opinion, should be used in jobs where precise accuracy is not needed and as a last resort or as a backup. Let's move on. Now, network RTK and NTRIP. What this is you connect the drone itself to an NTRIP network, getting RTK directly to the aircraft on board. How you would go about doing this is you're going to connect your controller to the internet and to your drone. Through said controller, you're going to log on to the mount point and then confirm that you have a secure internet connection. You then fly your AOI and collect your corrected data. Some of the pros and cons with this method. This method is utilized by smaller drones traditionally, like the Mavic Enterprise Advanced and the new Autel Evo Enterprise. This method, because it uses an NTRIP network and live RTK data, it can be backed up with the incorporations of GCPs, something that I always recommend. GCPs are a great way to make sure that the data that you are getting is accurate and reliable. Now, with the right NTRIP network, this method can yield incredibly accurate results. 2 centimeters or 1 inch accuracy horizontal and vertically as well. This is before the incorporation of any GCPs, and with accurate incorporation of 1 or 2 GCPs with this RTK method, you can get as accurate as any GNSS base station on the market. Now, one of the main drawbacks from this kind of positioning data is your area of interest has to be in an area of good cell reception during the entirety of the project. Because if your cell service dips or disconnects for any reason, whether that be your phone dying, you accidentally switching off your hotspot, if you're connected to a Wi-Fi network in a building and the bandwidth can't support it, your drone will continue to fly and continue to collect data, but it will have no RTK, there will be no notification, and there will be no way of knowing that you have bad data until you go to process it in post. In summary, this method is highly accurate, but not very reliable, and it can be rather hard to use and limited by the amount of places that you can use it. Like I said, if you don't have any kind of strong cell service or available Wi-Fi network, this method is completely unusable. Going to the next one, third-party base station. What this is this is a better version of PPK processing. What that means is there is no live correction data coming from this method. How you would incorporate this is you're going to set up your base station on your area of interest before you launch your drone, and then begin to collect your PPK RINEX data, preferably below 1 megahertz. And then you're going to disconnect the RTK on your drone and then fly the area of interest, collecting data. The data that you're going to be collecting is not going to be GNSS corrected data. It is only going to be corrected with the satellites that the drone is connected to. And then you take your drone data and you take the RINEX data that your base station was collecting, and you merge these two in post. Now, some of the pros and cons with this method is it utilizes existing technology that every survey company has. If you're in a survey company, you are going to be with manned data. You are going to have some kind of base station or some kind of total station that can collect PPK data. And it doesn't need a network, so you get around having to use a cell service. It allows you to use this method in highly rural areas. Now, some of the drawbacks of this method is it's traditionally slightly less accurate than live RTK data. And like the previous two methods, there's no way of checking for errors in the data until you're back with post. There's no notification that your base station dropped its satellites. There's no notification that your drone is on a different collecting on a different datum than your total station or anything else like this. This method can also result in a point cloud, quote unquote, noise or drifting points because of the reference structure of the RINEX data and how it collaborates with drone data. Now, in summary, while this method may take very, very little setup and very little extra knowledge, the accuracy is less than that of a live RTK, and some satellite errors and unexpected noise can result in multiple repeat trips to the site, as well as incredibly long processing times before you can actually have deliverables on your drone data. Moving on, third-party base station with the NTRIP. Now, what this is you're going to be using the base station to host and stream a direct connection to the NTRIP network to the drone. This is only another version of a live RTK data. So how you would go about doing this is you connect your base station to the mount point of your NTRIP network, and then you set it to broadcast to your drone at the right frequency. You make sure that your drone is connected to your NTRIP network through your base station and receiving data before you fly, and then you fly your AOI. You collect corrected GNSS data as your drone is flying, just like with the previous NTRIP network. Some of the pros and cons, like the other previous method, like I said, it utilizes existing equipment. However, there is far more setup. This isn't a plug and play situation with this reference structure. If you do set up this method correctly, it can produce incredibly high accuracy like the live NTRIP network, 1 inch or 2 centimeters horizontal and vertical. And because you're using a base station to jump onto the NTRIP network, you are not limited by the hassle of constant cell service. And because you are not using a PPK method, this is like I said, a live RTK correction method. You can take PPK or GCPs or RINEX data as a backup to reference the accuracy of your data, or as a backup if you have any problems with the connectivity or the NTRIP network itself. The main problem with this method is the complexity of the setting up. Now, setting up of an NTRIP network connection from the base station to the live network is going to have a different configuration for every setup that you use. Topcon has a different workflow than Trimble, and Trimble has a different workflow than Topcon, and both of them are different depending on which drone you're going to be using. And then most of the smaller drones that use direct NTRIP network connections actually cannot use this because they have no way of picking up the broadcasted signal from the base station. So this would be something on a larger drone like your M300. Not only do you have to configure the base station to connect to the NTRIP network live, you have to configure it so it broadcasts the correction stream so that the aircraft can read it and make sure that you're in the same datum. So like I said, every base station will be different for this procedure, and it takes a deep technological understanding of the base station that you're using and your NTRIP network. So while this method can yield incredibly high accurate results with existing equipment in a fairly reliable method, the setup is incredibly long and can be highly technically frustrating. And if you don't do everything completely right on your setup, you can actually end up in quite a few revisits and reflies of the same area of interest. Now, finally, last but not least, is the D-RTK2, used to stream live correction data directly to your drone in flight. How you would implement this is you set up your D-RTK2 base station in your AOI, let it warm up connection to its GLONASS and Galileo satellites, for 10 to 15 minutes. You make sure that the drone is connected to your station, and then fly your AOE, getting corrected data. And during this workflow, you can monitor the entire flight to make sure that it is connected to your RTK during the entirety of the flight. Some of the pros and cons, the setup for this is incredibly easy when compared to your third-party base station with the NTRIP network. It's a literal plug and play. This method does not need cell coverage, and because of the satellites that the DRTK2 can yield as accurate results as an NTRIP network in most cases, if there was a failure, that doesn't happen very often, but if there is a failure, because of the compatibility of programming, because the DRTK2 was made by DJI, is communicating with a DJI drone, and if you're using a DJI payload, because of the seamless connection, your drone will notify you as soon as you drop RTK data. This is something that isn't found in any of the other methods. And what it does is it lets you troubleshoot on site rather than finding this error or this RTK drop on site, rather than finding it in post and having to come back and try to fly the same site once again. And because you are using a live stream RTK data, just like with your third-party base station in the NTRIP, you can use traditional PPK methods to back up and check your work, making this this method incredibly reliable, incredibly accurate, and incredibly easy to use. Some of the only downside to this method is the fact that you have to purchase and learn how to use a new base station. This often means bringing 2 different base stations to one job, one for flying and a second one for taking PPK data as backup, which I always recommend. In summary, there is no one method that is perfect for every job. Some are simpler to learn that yield more precise results. Some are harder to learn but use existing equipment and don't require any further learning. I hope that with this information, you and your team can make an informed decision about which GNSS correction method will work for you and for your company to get you the data that you need. If you have any questions about what we discussed today, or feel free to put them in the question box. I will be answering questions for a couple of minutes after we finish with the webinar, as well as if you have any in-depth questions, I do ask that rather than putting them in the question box, that you email me directly here at tcrete@multicopterwarehouse.com. If you are interested in a personalized quote, feel free to send me an email or reach out with my direct office line here on the screen, 303-638-8611. Thank you so much for your time, everybody that attended, and here I will start to answer some of your guys' questions. Now, let's get over here. So some of the first ones, so thoughts on the MLED RS2 using their casters, the P4 RTK. I'm incredibly well versed in the DJI's DRTK2, and I haven't had a chance to branch into others like the Topcon or the MLED. If you'd like, I can do some research on that guy with some of the workflows and get back to you shortly. Just send me an email and I can answer that question for you there. Another question, the DRTK2 does not use a paid subscription. It connects to the satellites, does not use a cell service, does not use an NTRIP network, so there is no need for a paid subscription. Can I use PPK process data from the DRTK2? Now, the DRTK2 does not produce Rhinex data, so you can't use it like the PPK with a third party. However, if you have 2 of the DRTK2 base stations, you can set one of them up as a base station and one of them up as a rover. And you can use a DRTK2 to mark points like a traditional PPK, put out your targets, mark your points, and then fly them. So methods compared to the M600P using only GCPs. What that method is using only GCPs is that traditional PPK method that we talked about absolutely first. So like I said, it's been around the longest. If you take your points well with with good quality equipment and you are precise in your inputting of the data, it can be incredibly accurate, just like everybody has been using, but it does increase your processing time. It does increase your time spent on site as well. So that live RTK data, it allows you to take accurate data the first time without GCPs. Now, does that mean that you should fly without them? Absolutely not. I highly recommend getting at least 1 or 2 GCPs whenever you use live RTK data as backup and something that you can check your work. No system is perfect. GLONASS and Galileo satellites don't fail often, but if they do, your system could think that it's getting good live RTK data, and it's not. So always take at least 1 or 2, preferably up to 5 GCPs whenever you're using RTK data. The DRTK2 expected accuracy, if you read the DJI spec sheet, it's expected 2 centimeter horizontal and 3 centimeter or 1.5 inches vertical. Now, in practice that I've seen, it gets pretty close to that, and after talking to several survey companies that use the DRTK2 in their workflows, they're getting about 3 to 4 centimeters horizontal and about 3 to 5 centimeters vertical with that raw RTK data. And then with the incorporation of a single 2-3 GCPs, you can make that as accurate as you would like, getting that sub-inch accuracy that most surveyors need. Is there any more questions? If not, we'll probably wrap up here shortly. Again, thank you guys so much for attending this webinar. If you have any other questions, don't want to put them in the chat, or something that takes a little bit more detail, please feel free to send me an email and I will get back to you as quickly as possible. Thanks everybody. I hope you have a wonderful rest of your day.